Okay, good afternoon, everyone. Thank you for attending today's webinar. My name is Erica DeLello. I'm a project manager for RESCheck, and I'm here today with Robbie Schwartz. This series is sponsored by the Colorado Energy Office with training materials created by BuildTank. Robbie and I have been working with the Energy Office for just like this one. This is the second of, sorry, one second. I have to turn my video off. This is the second of our webinar series. As you can see, we've got several more on the docket, so definitely check those out if you're not already registered. We do also offer tailored group trainings, and we have a new type of training. It's called role-based training that we'll be doing a road trip of sorts throughout the next few months to target specific audiences throughout the state so that we can train them on their roles as it relates to complying with the energy code. So definitely keep an eye out for that. Or if you're interested in setting something up, or for training wise, or if you have a need for technical assistance for code adoption, we also support that as well. So if you need any kind of assistance or grant writing assistance, or there's a lot of different types of technical assistance that we can offer. So definitely reach out if you have questions. And then lastly, I want to highlight the Colorado Codes helpline, and the helpline is available to anyone in Colorado on any of the I codes or REACH codes. So for example, if you are a jurisdiction and in need of assistance on a plan review, or a homeowner or engineer with a question about code applicability, you can submit a ticket and a subject matter expert will get back to you in just a couple days time. I do want to note that this is a new platform. We switched platforms from what we were using previously. So this is a new link. If you scan that QR code, it'll bring you right there if you'd like to submit a ticket. All right, so we do want to encourage questions, but we're going to use that Q&A function so Robbie can get through all of his content, and then we'll leave time at the end for questions. There is also the ability to raise your hand and ask a question at the end of the presentation, and I can unmute you. And then lastly, there's a survey window that pops up following the webinar, so please take a minute to provide that feedback so we can continue to improve on these webinars. All right, so today's presenter is Robbie Schwartz. And Robbie founded BuildTank Inc. to be a practical building think tank to do research, education, and work with builders to ensure that their homes not only comply with codes and programs, but perform as well. So with that, I will let Robbie take it from here and share his screen.
Terrific. Welcome, everybody, and thanks so much for joining us on this beautiful day. We're going to talk about RESCheck, and we're actually going to do create a RESCheck model. So I should have coordinated, I think, a little bit better with Erica, but because it's going to be a little bit more interactive, I'm going to show you some sets of plans, and we're going to work together to understand what information we need from the plans to put into the RESCheck model, and we're going to build one as we go along here. So I'll ask some questions, and you can type in answers to it in the chat or the question answer thing. And then if you have questions as we go along, ask those as well. And I'm going to have to ask you, Erica, if you don't mind monitoring the question pane with me, so that we make sure that we get questions, because we're going to be actually building that energy model as we go. Therefore, you might have questions as we go along, and it might be more appropriate to answer them as we go rather than at the end in this particular case. So,
okay, sounds good.
Yeah. So everyone can see the screen here, and I wanted to make sure that we know how to actually get to the RESCheck software. RESCheck software is a free software that's been developed through the Department of Energy partnership with Pacific Northwest Labs. You can just Google RESCheck, and it will come to this page. And obviously you just hit login here. And if you don't have an account already, you would go in and you would create account. You would sign in and create an account. I already have an account here, so it takes me directly to it there. Um, what's nice about the ResCheck software nowadays is that it's an online based software. It's not a software that where you would download the software and then install it on your system. It's all online. And you can see how it's structured here. When you create a project, you get a list of your projects and it just houses them in the cloud there for you. And if you want to share the project with somebody, you can do that. So you could have builders or architects or whoever's doing the ResCheck share it with you as a jurisdiction having authority, or you can share it with maybe an insulator or somebody else. You could share the ResCheck as well. It's pretty, you know, pretty easy to work your way through it, and that's what we're going to actually do today. So the first thing I'm going to do is I'm going to start a new project there. So I hit the new project, and I want to name it something. And I've done this before, so I'm going to name it example ResCheck here. Then we have to associate the ResCheck calculation to the code that we're actually working with. Now, these codes, these older codes, the 2009 and 2012 IECC are no longer supported by PNNL. And at some point, they're probably going to get just fall off. But if you're still on these older codes, know that they're not supported by PNNL anymore. So that if there are any tweaks to the software that has to happen, we've lost our opportunity for that. I'm going to choose the 2021 IECC, but I also wanted to point out here that some jurisdictions, like the city of Denver, for example, in their new code adoption, they adopted basically the 2021 IECC with some pretty heavy amendments to it, and they call it the 2022 Denver Energy Code. So for the residential compliance, one potential is to use ResCheck, and because of the amendments that they made, they decided to hire PNNL to do a ResCheck specific software modification. So if you're doing a project in the city and county of Denver, then you would need to go to this version of ResCheck rather than just the 2021 IECC. Which brings up a question that Eric and I were discussing before we got on the webinar here, that some jurisdictions might not have the funds or the ability to hire PNNL to do this type of calculation specific for your jurisdiction, yet you still want to amend the code in some way. Maybe you're amending the R value table or the U value table, for example. What you can do instead of that is put in your adoption that the house needs to be a certain percentage better than the reference home or the 2021 compliance. And the easy way to do that is to take your amendments into ResCheck and model a few houses, and you could get an idea: are my amendments achieving 5% better, 10% better? And I'll show you this idea of being better than. I'll show you at the end here, but that is something that you could easily do here. So anyway, I'm going to choose the 2021 IECC. We're going to need to, you don't really need to locate the house so much because this isn't a software that uses hourly data or weather data per se, but it does give you that option to do that. It's good to know for you as a jurisdiction when you're accepting it that they're obviously doing this specific for your jurisdiction. So I would actually require it, but I just wanted to make sure that it's understood that it's not hitting external weather data there. There's also these information tabs that gives you some information about the entry and whatnot, so that if you do have questions going along, you can do that. Now, remember, ResCheck is a prescriptive compliance option, so that for existing buildings, you could just do a ResCheck on the addition. It's in and of itself. You don't have to take into account the entire building plus the addition, like you might have to do with the simulated building performance approach, the R405 approach, or the energy rating index approach. So this is going to be new construction. We're not doing an addition or alteration. We're going to do the area weighted trade-off approach, and you'll see here that they have a performance alternative, but there's no information to it. It looks like there's no information on the UA approach as well. And the reality is that this software does not do a performance compliance approach. So you should never accept it if they had this button picked here. And I guess I hadn't realized this, but you get this notice that comes up as well here. The performance alternative is based on the simulated performance of your proposed building, but the reality is that it doesn't use the reference home that's in the R405 section, and it doesn't give you a cost compliance report at the end. So it is not a software that is capable of doing compliance using the R405 section of the code. PNNL knows that. I think there was an aspiration to get it to that point where you could use it. They ran out of funds or something. I don't know what, but it cannot be used for that level of compliance. It can only be used for the area weighted trade-off approach for compliance here. Additional efficiency package options come into play here for the 2021 IECC. So we have to go in to that and we have to choose which efficiency package we're going to use. And in the area weighted U-value compliance approach, you have to choose one of the compliance options, one of these options here. So you have a choice of enhanced envelope performance, HVAC and efficiency, so higher, high efficiency HVAC equipment. It doesn't force you to go to all electric. You can use like a heat pump, or you could use a high efficiency AFUE 90%. I think it has to be better than a 92% AFUE furnace. More efficient water heating, same principle as for space heating. Better thermal distribution performance, meaning that your ductwork is located inside the conditioned space and it's reaching a certain level of air tightness. And then more efficient air sealing and ventilation performance as well. So I'm going to choose a more efficient HVAC system for this, and we'll hit continue there. And then eventually it should ask me for what is the efficiency of the HVAC system that I'm going to install. Now the construction site here, I just put in my home address, but you'd want to put in the home address if you have the permit number and permit date. You can add notes here. You can add in information for the owner or agent of the house and for the design and or contractor as well here. So that's interesting stuff. And then we want to go into the construction type. So it's the house we're going to do is a single family detached home, not a multifamily home. The conditioned floor area is the next thing that we need to do. So I'm going to bring over the set of plans here. And Erica, maybe you can let me know if I have to reshare my screen to be able to see the set of plans.
Nope, we can see it.
Okay, perfect. So this is a pretty easy set of plans. It's just a ranch style house under a ventilated attic that has an attached garage on it. So we're going to go to page 2 here, and you can get an idea of the feel for the house. So our first kind of data input is what is the square footage of the house? And I'll blow this up a little bit, and I'm going to ask you guys to calculate the square footage of the house. We have a 30, it's pretty much a square. We don't ever include the garage in the conditioned square footage of the house. And I guess I should point that out as well, that even if the garage is insulated, the thermal envelope is always considered at the boundary condition between the conditioned habitable space of the house and the garage. Even if the garage is conditioned, it's never considered habitable. And that's the big distinction point there. So you would never include the square footage and the square footage of the house. You would never include the volume of the garage in the volume of the house when you're doing a blower door test as well. The garage would always be separated from the house for that blower door test. And our boundary is here. This is what we want to be airtight to separate the conditioned space of the house from the conditioned space of the garage. So when we calculate our square footage, we're just taking the 32 times 42. So do that calculation. If you can pull out your phone calculator, if you have a calculator next to you,
Looks like
32.
we got one response already.
Okay.
144 square feet.
Okay, great. Okay, so we come back here, and that's the first thing we're going to add is 1344 for our square footage. And we'll go back to the plans as we go along here. We have the option of putting in the orientation of the house. Again, it's not going to impact our compliance using the area weighted trade-off approach, but maybe we'll put that in and we'll say, and this would be based on the front door, what direction the front door is facing. So if I'm standing in front of the house and I'm looking at the front door, that would mean the direction that's behind me would be the direction. So if I'm standing in front of the house and behind me is north, then that is the direction, the cardinal direction of the house here. These are other things that we can add in here. All ducts and air handlers are located in conditioned space. Well, we'll say no here. Ducts are buried in ceiling insulation. I'm going to say no. Thermally isolated sunroom. This house doesn't have a sunroom. Pool and indoor spas. Nope. Interior wood burning fireplace. Well, maybe I'll put yes there because this house is actually located down in the San Luis Valley. So all electric property. Nope. Renewable energy installed? Nope. Battery storage? Nope. EV charger? Nope. And heat pump? Nope. Now, again, really the majority of the stuff, actually none of this stuff really matters from the true perspective of compliance based off of area weighted U value. Remember, when we're talking about area weighted U values and U values in and of themselves, we're talking about basically the R value of the assembly of things, not just the components. So U values are used for assemblies to discuss the resistance to the flow of energy from higher concentrations to lower concentrations across an assembly. And R values are used for the components within that assembly. And that's why, for example, we always talk about windows as a U value because the window is an assembly of different things. We have the sash, we have the glass, we have the edge spacer, all those different things coming together. And I can't describe that as an R value. I could describe the glass in itself as an R value, but not the whole assembly. So in the same way, we are trying to calculate the U value of all of these different assemblies that create the building thermal envelope of the house. And you can see that even though I put interior wood fireplace in this house, it doesn't matter at all from the perspective of calculating the U value of the assemblies here. So I'm not sure why they put it there and give you the options, except to maybe give you, as the code official, potentially more information about the house here. Okay, so you always want to save your project here. So we forgot to enter the project location. So I'm going to enter Denver in there again, Denver, Colorado, and I'm going to save. So you want to save your project so that you have, because it's online and whatnot. Who knows? Your power might go out. Who knows what might happen? So the next thing we're going to go into is we're going to start entering this house into the software. So you remember how softwares work. If you've taken any class from me, I've probably told you before that the software creates two homes within the body of the software. So we enter the geometry of the house into the software. The software creates two homes that are geometric twins of each other. You can think of them as my two hands. One house is overlaid with the code requirements from the U value table, in this case, there. The other house is overlaid with whatever the builder wants to do. So if this house is equal to or better than the code reference home, then it's going to be in compliance with the code. And that's what we're ultimately trying to get, is a report that tells us if the house I want to build is equal to or better than the code, and it gives me the ability to do what we call trade-offs. So the 2021 says I have to build with an R60 attic insulation. I say, I don't want to do that. I just don't understand why I need to do that. Well, I can trade that off potentially if I do something more in a different assembly. So we're going to start building our assemblies here. And we're going to start with ceilings. So I go into ceilings here, and I'm going to hit add ceiling. And it gives me a choice of different types of ceilings I can add. Can add a flat ceiling or scissor truss, cathedral, raised or energy truss, and all these other types of things. So we're going to add a flat ceiling. We're going to tell it its gross area is the same footprint as the footprint of the house, so the same square footage as the foot of the house, so it would be 1344. And we're going to, let's say, well, there's no cavity. Well, actually, there is some cavity insulation. This is one thing that we can think of. So let's say I've got a truss in that house, and the bottom cord of that truss would house cavity insulation. So if I'm installing blown fiberglass, for example, with a R value of about 4 per inch, then I would have, if my bottom cord of my truss was 3.5 and my R value per inch was 4, what would be the R value for the bottom cord of the truss that I would want to enter there? Maybe you could throw that into the question pane or chat button there. So it would just be 3.5 times 4. And we would get 14 for that cavity insulation. Now, well, anyway, so you'd have to double check that the fiberglass that you're using is actually 4 per inch, but let's say it's 4 per inch here. And I want to do R38 attic insulation instead of R60 attic insulation. So I need to take R38 or 38 minus 14 because that's my cavity insulation. And I'm going to enter 24 for my continuous insulation. So I have this insulation that's in between the bottom cords of the truss, and then I have this continuous insulation that's over the entirety of the house there as well. Now, one of the things we need to think about, I'm going to apply this real quick so that we can see it after we've made that entry. If you have any questions about this, don't hesitate to ask that now. But one of the things we need to think about here is that there's a requirement in the IECC that says in the specific insulation installation section in the R402 sections of the code, it says that you can trade off prescriptively from an R60 to an R49 if the full value of R49 insulation is installed over the top plate. So there's an installation requirement and there's a requirement for the R value there. So we're trading off the R value here. We're not going to R49. We're going to see if R38 will work, but I still have to address that installation requirement, which means that I either have to have a raised hill truss or I need to do a further trade-off and break out the perimeter of that attic there that is coming down to the top plate where I might not have a raised hill truss to be able to receive an R38 insulation there. So let's say I don't have it, but I have, like, let's say a common 6-inch heel or bird mouth on my truss system there. So I need to go back and first I need to look and see, do they have any truss drawings here? So we can look here and see that they have some truss drawings on my plan set here, but that truss drawing is not a raised hill truss. So this, I need to know what that height is over the top plate here and how much insulation I could probably get there. And I'm going to say, I'm just going to assume that it's about 6 inches there. So if we go back over here, I can add another ceiling entry here, and I can name the ceiling entry ceiling. Let's say I'm going to name it ceiling at eve 20%. And I'm going to call it a flat ceiling as well. And my gross area now would be the 1344, would be 20% of that. So times 0.2, and I'd get about 269 square feet of that. I would have, I would say, well, we have to decide, should there be some cavity insulation or should it just be continuous insulation? I think we keep it at the cavity insulation of 14. And then if we go 6 times 4, because remember, R value 4 per inch for the fiberglass, and we have a 6-foot height here. So if I go 6 times 4, that gives me an R value of 24 over the top plate. So I have to if I'm going to put 10 of that or 14 of that R value in the cavity, I need to put 10 of that R value as the continuous insulation over the top plate there. So I'm going to apply that. And then I need to actually come in here and adjust this square footage. I need to take the 1344 minus the 269 here, and I get 1075. So now I have a flat ceiling that doesn't have a raised hill truss, and I've taken into account the non-raised hill truss over here, and I've called it out as ceiling ceiling at attic eave 20%. And if you could require, if you want, better descriptions there, so I could actually say ceiling at eave at 20%, no raised hill truss. I could name it that so that it would be easier for you as a jurisdiction when you review it there.
Hey, Robbie,
But yeah,
I've got a question for you.
okay.
So continuous and cavity add up to total installation depth from ceiling upwards. Is that correct?
Yes, correct. Yeah. So we have the cavity insulation, and in our case, it's 14 between our two studs. And then on top of that, we have the continuous insulation that goes over all of those bottom cords of the truss. There. Yes.
Thank you.
Yeah. Okay, so but I just wanted to point that out, though, that's a big thing that we need to be looking at, is that requirement there's basically a requirement for a raised hill truss, but it's not specifically spelled out as a raised hill truss there. So it is something that we need to look at when we do our plan reviews and ensure that we're going to get into our house. So the next thing we're going to do is we're going to start adding walls. So I'm going to call this is a 2x6 wall, framed 16 inches on center. So it's a wood framed wall, 16 inches on center. I'm going to break them out here. So the first one I'm going to do is the wall to the garage. The reason I break them out is that I have to associate a window or door to the wall, so that in essence, the window or door that I associate to it is broken out, is taken out of that wall. It looks like we might have another question. How can you have continuous at the eave with eave trusses sitting on the wall? Well, that's a great question, and we can go in and fix that there. So let me just finish with the wall here, and we'll go in and fix that. So we need to go back to our plan set here, and we're going to go back up to this section, and we're going to need to get the dimension of this common wall between the house and the garage. So it's 24 feet here. And our ceiling height is 8 feet, which we can get from probably our sectional drawings. Let's see if I can find the sectional drawing real quick. Up here. We might be able to get from our sectional or elevation drawing. So it tells us that we have an 8-foot ceiling here. So if I take 24 times 8, what do we get? We get 192, right? Orientation, it's front side of the house. Cavity insulation, let's say it's a blown fiberglass, 23. We don't have any continuous insulation. So we're trying to trade off two things here. We're trying to trade off continuous insulation and our attic insulation. And we'll see if we can do that or not. So I can apply that to it. So I have my front of house here. Let's go back and address the question from Janet here that is basically saying we don't have any continuous insulation. So we're going to make that 0. See if I can make that 0. And we're going to make this 24 just over the top plate there. Okay, so that's how you would do that, Janet. And that's a great catch. Great way to make our model a little bit more accurate here. Okay, so if I go back to our plans, we'll see here that there is a door between the house and the garage. I don't necessarily have the exact size of that, but I'm going to guess it's pretty common that it's a 3080 or a 3080 door, so it would be 24 square feet. And so I need to enter that door and associate it to this wall here. So let's see if I need to remember how to do that. Oh, I add a door. It's pretty straightforward. Door to garage. It'd be a solid door under 50% glazing. And it's 24 square feet, and it's common that the insulated doors between the house and the garage is an R6 door. So you have to convert that to a U value. So we take 1 divided by 6 to get a U value of 0.16 for our U value for that door. And you can see I have my garage wall, and then underneath it here, I have a door that's associated to that wall. So my total square footage of my wall is 192, and 24 square feet is subtracted out. So I have a little bit less at R23, and then I have the 24 square feet at a U factor of 0.16 there. So I'm going to add in another wall, and it's going to still be a 2x6 wall. In this case, this is wall let's say to front of house. And we have to go back to our house here. And we see that the front of the house is 42 feet long. So 42 times 8 is 336. So 336. Orientation is front. Cavity is 23 still, and I'm still saying that we have no insulation there. Which means actually I need to go back in and edit this because this isn't to the front of house. We'll just do unspecified because it doesn't give us the ability to do that. We could do it to the left of the house as well, I guess, there. So maybe I'll do that real quick. Okay, so I'm going to add a door. So we can go in back to our plans. And in this case, we can go over here. And we can see we have a door that's a 3.0 door. We have a window, 1, 2, 3 windows that are 3x5 windows. So that's 15 square feet of window. So we have a total of 45 square feet of window and 24 square feet of door that we need to add to that front wall, in essence. So we're starting with the door. We're going to call it a solid door again. It's 24 square feet, and it's still that 0.16, we'll call it. 0.16. That's R6 door. We can call this the front door so that everybody knows that this is the front of the house. We're going to put in the front door there. But why did it associate it to this wall? This wall. We need to move this. I think we can just grab it, if I remember correctly. Maybe I have to do it that way. Let's see here. Oh, okay. That's what I did. I forgot to change it up here. So I went into the edit function, which is the little pencil there, and then I have to apply it to the right assembly here. So I need to apply it to the front wall, and therefore we have our front door now associated with the front wall here. So I'm going to now add windows, and our windows are, we want to associate it to the front wall. It's a vinyl framed window, double pane low E. And what does the code say that our minimum requirement or minimum U value and solar heat gain coefficient for windows is in climate zone 5? Anybody know off the top of their head? We had that 45 square feet, and we're going to put in a 0.30 window there. Now, we'll come back to that as well. Okay, so then we have two more entries. We have this right wall, which is 32 feet long. We have the back wall, and we actually have this little piece of wall over here to enter as well. So the right wall we'll do first, and we have one window in the right wall, which is a 1.6, which is 1 foot, 1.5 feet by 3 foot window that we need to put into our right wall. So we're going to add another wall. We're going to call it right. It's a 2 by 6, 16 inches on center. It's 32 feet long by 8 feet high, which 256. It's facing the right side. Cavity insulation is 23 there. Then I'm going to associate that window to that wall. So I have to put it into the right wall. We're going to call it a vinyl framed window. It's double pane low E. It's 1.5 square feet or 1.5 feet by 3 feet. So it's a 4.5 foot windows, gross window at a U factor of 0.30, and apply that. And you can see that underneath the right wall, we have that window associated with it. We need to add our back wall, which is a 16 inches on center again. It's the same square footage as the wall to the front. So it's 336 square feet. It's facing the back of the house. And it's at 23 R value again there. We need to go double check what do we have going on here. We have a Windows that's a 3.5, a 2.3, a 3.36, and another door to the outside there. So we can do our 3.5 window times, 3.5 times 3, which gives me 10 square feet of glass for that window. 10.5 square feet. We have 2 times 3, which is a 6 square foot window, and a 3 times 5, which is a 15 square foot window. So our total glass is, if we add all that up, we have 31.5 square feet of glass. And I'm just going to use the same 24 for the door, even though it is a little bit smaller. So you might want to double check that as well. So we have our where's our right wall, front wall, garage wall. Maybe I didn't add it. I thought I added it already. Anyway, so we're going to add that wall. We're going to call it to the back of the house. Cavities 23. Apply it. Oh, we didn't do our square footage. Front, right. Oh, here it is here. Okay. Okay, so we have our wall. Now we need to apply the windows to that wall. So again, we have a vinyl frame. We're going to apply it to the back wall. We have a double pane low E window. We calculated the total square foot at 31.5 and a U factor of 0.30 again. And we have a door that we need to apply to that that wall as well, which is on the back wall. It's we'll say it's the same as what we had before, just for ease here. Okay, so the only thing that I need to add now is this little section of wall that's not adjacent to the garage because of the way I broke it out. And we see that's 8 foot, so it's an 8x8 wall, and there's no window or door associated with it. So I have one more entry here, which is a wall. It's 2x6, 16-inch on center again. It's facing the right. So we need to specify its orientation. And it's an 8x8 wall, which is 8 times 8 is 64. And it's also insulated to 23. Okay, so I have my ceiling entries here. I have my wall and window and door entries here. The last thing I need to enter is my foundations here. It looks like we have a question. So general question, is it better practice to combine the windows and doors per wall or list them separately? The calculation would be the same. If you combined all the wall together, then you could subtract out all the window from that wall. You have to associate a window to a wall. I like to go around front, right, back, left, around the house, so I make sure that I don't forget anything. But it's really up to you. I also think that if you as a jurisdiction got the RESCheck that we're doing together, that it's easier for you to read and to review because you see each of the components broken out in such a way, and they've been labeled. So you know it's the front wall or the wall to the garage. You know that there's a door. Yep, he took that into account. On the front, there's a front door and there's windows, and you basically have an idea that you've taken everything into account. But yes, you are right that you could do it either way. You could add them all up as a gross and then take it out of it. Yes, I mean, basically you're correct there. What about putting each window in separately? Yes, you could do that as well. And if you know that the windows have different U values, you might want to do that there. We're making the assumption is that the code allows us to have an area weighted U value entry for our windows, and so that's what we're utilizing there. Okay, so
one more question for you, Robbie.
Sure.
Are the areas of windows and doors removed from the wall area?
Yes, yes. That's why I need to associate the window to the wall. So basically, the wall that's being modeled would be the 336 minus the 24 minus the 45 for the windows here. So
Perfect.
yes.
Thank you.
Okay, so we have a foundation to add here. We have to call it either a floor, which enter the applicable floor type for slabs on grade. This is a slab on grade. You can enter a basement and you can get a little bit more information about basement and crawl spaces. So we're going to start with a floor. It's a slab on grade. It's an unheated slab on grade, and it gives you this additional information here. Now, this is something that came up maybe last year or the year before, that in the only place that slab edge is insulation and the required R value is mentioned is actually in the R value table, not the U value table. And the U value table is what we're trading off here. So what they're saying here is that you cannot trade off slab edge insulation if you utilize the Pacific Northwest Labs version of the RESCheck software. If you're using the RESCheck software to calculate the area weighted trade-off approach, they will not allow you to trade off slab edge insulation for something else here, because when you get into looking at heat loss through a slab to the earth, it's actually called what's called an F factor rather than a U factor, and it's calculated differently. And interestingly, in the 2024 IECC, they've solved that issue. They've added actually F factors into the U value table, what used to be called the U value table and the R value table there, so that you can trade them off again. But from PNNL's perspective, or Pacific Northwest Labs perspective, you are not allowed to trade off insulation at your slab. You're required to enter it. And then also in the 2021 in our climate zone here, climate zone 5, you used to have to come down from the top of the slab or the top of the foundation, basically where the foundation meets the wood framing, down 4 feet or down 2 feet, or down a foot and out 2 feet. Now you have to go down a total of 4 feet, and that can be horizontally or vertically. So in this case, let's use this example over here. They're going down 1 foot and over 3 feet, for example, to get the total of 4 feet below grade insulation. You can go down and out. You can go down and in. You can just go down if you have a 4-foot stem wall. But in essence, you have to insulate from the sill plate down to the footing if you're going down just down vertically there. If you're going to go horizontally, you can make those choices here. Okay, so this floor, I'm going to name it a slab on grade so that everybody knows that it's not like a cantilever or a floor over garage or anything like that. The perimeter.
And Robbie, is the 4 feet specific to 2018 or just 2021?
It's specific to the 2021, that change there.
Thank you.
So our perimeter length of the slab is, remember, the front of the house was 42 and the side of the house was 32. So we just add that up, 42 plus 42 plus 32 plus 32. And we get the total perimeter of our house at 148. It's required to be insulated to an R10 for slab, and it's required to be 4 feet. And we're just going to call it vertical insulation there instead of our other options. If we fully insulated underneath the slab, this would be where we get into, if this is where you get into a heated slab scenario there. If you're insulating underneath the slab in its entirety, you still have to insulate the slab edge, but you can also insulate underneath the slab if you had a heated floor there. Okay, so I apply that and I have my foundation. There we go. I have my foundation. So I also want to always make sure that I saved everything. And at this point, I could go in and I could check for compliance. And I go over here and I look, oh no, I am not compliant. I am 2.3% worse than the code here, which means that I could either go in and adjust my attic insulation. Maybe I could get R49 attic insulation there, or I could adjust my continuous insulation, or maybe I install better windows than are typically better than that 0.30 window. Maybe I've always chosen to use a 0.25 window instead of a 0.30 window there. So let's do a quick poll in the chat there. Do you want to change the windows? Do you want to change the attic insulation, or do you want to change continuous insulation? Windows, attic insulation, windows. Okay, it looks like we're getting most windows. And I'd say that's, it's probably the most, it's not the most cost-effective way to build the house, but if you really want to trade off attic insulation and continuous insulation, windows is the easiest way to do that there. So we need to come into each of our window assemblies there. And our first one is here. So we're going to put in, let's put in a 0.25 window. Here's another window, 0.25, and another window, 0.25. I'm going to save that real quick and demonstrate compliance. And look, lo and behold, I am compliant at 0.8% better than. So one of the best things about modeling, this is not a very sophisticated energy model compared to the modeling that's used for the simulated performance approach, the R405, and the energy rating index approach, but it does give you the ability to try to figure out the most cost-effective way to build the house the way that you want. And I would say right now, most builders want to trade off that continuous insulation. They can't trade off slab edge insulation using this software, but they do want to trade off slab insulation, especially that portion that is above grade that's so hard to detail. And a lot of them probably want to trade off to a lower or smaller raised tail truss there. So you can do that modeling to figure that out. So the question here is, so a better window makes up for the lack of continuous insulation. And that's true. That's exactly what the trade-off is doing here. Is we're doing something less in our attic, we're doing something less in our continuous insulation here, and we're doing something more somewhere else, which is our windows. And the windows, pure and simply, are the weakest link in our houses. And the better window you're putting in, and also the fewer windows you put in, the easier it is to trade things off there ultimately there. Okay, so I just want to make sure I save this here. I'm going to go into reports, and I'm going to print these reports real quick, and I wanted to show you the report.
We got a question for you, Robbie. How
Okay.
much better than code does RESCheck rate a home if we put in prescriptive values?
It generally does say that it's better than code, which is weird. It shouldn't do that. If you put in all those prescriptive values, and it varies, it's not a lot, but it could be between 1 and 2%, I think, something like that.
Okay, thanks. And
Yeah.
then one more question for you is what to do with the accessory parts of the house, garage, crawl area, crawl space, attic, etc., that are within the
Well,
thermal envelope.
the crawl, in this case, the garage is outside of the building thermal envelope, so I don't care about it with regards to compliance, because the energy code is only addressing the building thermal envelope and the conditioned space that is inside the building thermal envelope. Because remember, the definition of the building thermal envelope are those assemblies of things that create that boundary condition between conditioned space and unconditioned space. If I have a crawl space, I have to define it as either a conditioned crawl space where the insulation would be down the exterior walls, and I'd have to define that in the software, or I would be insulating and creating my boundary condition at the floor there, and I would need to define that in the RESCheck software.
Right, and you had mentioned earlier that it has to be a habitable space as well as conditioned. So to whoever submitted this
Or crawl
question,
space.
right, it's got to be habitable in order to include.
So maybe I need to say it slightly differently. It needs to be habitable and conditioned. So the crawl space is not habitable. It has to be one or the other or both, I guess. So the crawl space isn't habitable, but it is conditioned there, and it also is defined within the conditioned thermal boundary, the building thermal envelope boundary of the house, if you're doing a conditioned crawl space, in the same way that a conditioned basement would be. The garage could be conditioned, but it is never habitable. So that's what throws it outside of the building thermal envelope, is that it can never be habitable because we store our car there, we store paint, we store gas, all these noxious fumes that come off of those things. That air we don't want to sleep in there. So we always have that thermal boundary separating the garage from the house. There.
Perfect, thank you.
Okay. So we don't have tons of time here, but I want to make sure you're aware of the report. So we have the report here. You want to double check that they're doing it to the right code. They've described the building correctly. And then this is where you're going to determine if the house passes or not. So my house is at 127 area weighted U value versus 128. So it is 0.8% better. All it has to be is equal to or better than what we call the reference home. And the reference home is defined here as the maximum area weighted U value that's allowed, because the reference home, when I do that modeling and we create those two houses that are geometric twins, the U value table is overlaid by in the reference home, and my house is what we just created. The builder's house is what we just created. This house is equal to or better. In this case, it's 0.8% better. You should go in and double check that they got the square footages correct and that they are modeling the R values correctly. So let's say I put in, let's say I forgot to take this truss our square footage out of here. I would have too much attic area there. So you want to just do a basic check to double check that, and double check the R values and U values that they make sense. These things should be signed by whoever did it. Remember, a registered design professional doesn't have to do this. An approved third party, or even a builder, could do it themselves. Or sometimes you'll see HVAC contractors, energy raters, or insulators do this document. And then you have a code inspection checklist that can help you look at other requirements of the code there, that gets printed out by pretty much all the softwares, but RESCheck has this one that looks like this. And you could go into the RESCheck software. You could go into the RESCheck software. Where do I go? The last thing I wanted to show you. Oh, go back into projects, I think. There is a place to go through. I'm not remembering where it is here. Here it is. So I can go through these for the envelope and for systems in the house, and I can check off if these things are in the house. So some of these things were added before on the entry page, but on the systems page, you can go through these as well, and that can help to help the code official understand if that feature is actually in the house and they should inspect it or not there. So that's another thing. So just always remember to save your work, and then you can get here and you can demonstrate compliance. You can print the reports. You can go back to the home page and you could share this with somebody. So I could share it with Rob Salcido is director at Pacific Northwest Labs. And I could share this with him if I had questions, for example, or I could share it with you as a code official. I don't want to keep you forever, but if you have any questions, I'm happy to stick around for a little while and answer more questions, or we could try a different type of trade-off if anybody's interested in that.
Great. Thanks so much, Robbie. I'm going to go ahead and stop the recording, but I just want to thank everyone for attending, and we hope to see you next month as well. And yeah, Robbie and I will stay on the line for a few more minutes. If anyone has any follow-up questions, feel free to raise your hand or submit a question in the chat or Q&A.